The classical system is also used for multivalent metals. And we use it in the same way, and the way that we come up with the names or the formulas is similar to the stock system, but the naming of the metals itself is slightly different. So here we are going to be using Latin names of some of our metals, not all of them, but there will be 5 that you need to know the Latin names, and they will be used in the classical system. And the big thing with the classical system is that it is only used for metals that have 2 charges. So just some background on the classical system. It is actually the original system for multivalent metals. And most of these multivalent metals have 2 charges. So it worked for a long time. And then as advancements came along in technology and some more research into our elements, chemists realized that there are several elements in period 4 that have more than 2 charges. So elements like chromium, manganese, vanadium, titanium. I think those are the 4 main ones. And they have more than 2 charges. So this classical system that was being used at the time could no longer be used because it only works if you have 2 charges. So lots of the metals have 2 charges. And so as a result, we still use this system. Okay, it's outdated, but it is still used and used quite a bit. So this is why we have to learn it. Once you know the Latin names of some of these elements, all you're going to do is try to determine which charge is being used on your metal. And then you're going to use a suffix to indicate which charge it is. And we aren't specific as to the actual charge. All that we're doing is just saying, if it's the higher charge, and higher has an I in it, keep in mind, we're going to use the suffix "ic," which also has an I in it. If we have the lower charge, we're going to use the suffix "us," O-U-S, or O-U-S. And just keep in mind, again, a little trick, right? Lower has an O, us has an O, higher has an I, "ic" has an I. So just to help you if you find it difficult to remember. Here are the Latin names of the 5 elements you must know. Okay, so you must know these. Get my pen going. And some of them, some of the metals are used in the classical system, but we don't use their Latin name because they don't have a Latin name. But these 5 do. Au is the symbol for gold. And the reason that the symbol for gold is Au is based on its Latin name, which is aurum. Fe is iron, its Latin name is ferrum. Cu is copper, its Latin name is cuprum. Pb is the symbol for lead because the Latin name for lead is plumbum. Sn is the symbol for tin, and it is based on the Latin name stannum. You must know these 5. So now we put together the Latin names and the suffixes of these metals and come up with formulas and names of these compounds. So here we start with cupric chloride. So remember, Latin name of copper is cuprum, but we apply the suffix, either "ic" or "us," in order to denote what charge. "Ic" is the high charge. You go to copper. The high charge on copper is +2. Let me get my pen going, +2. And so just jot it down at the top. Chloride is the element chlorine. It has a charge of -1. We apply the crisscross rule. CuCl2 is the formula for it. Next door is ferric sulfate. So ferrum is the Latin name for iron. "Ic" is the suffix for the high charge. So you go to iron and you are only interested in the high charge. It is a +3. Sulfate is a polyatomic, ATE or ITE, always polyatomics. And sulfate has a charge of -2. We apply the crisscross rule and we won't have to reduce anything. We have Fe2 coming from the sulfate. We have to bracket this because it's a polyatomic. Sulfate's formula is SO4. We bring the 3 down. The next one is mercurous oxide. So here's an example of mercury being used with the classical system, but we're not using its Latin name. Mercury actually has a Latin name. It's hydroargentium. And I think it's just too long. The chemists never use it. So we're going to use mercury, and we just apply the suffix. So OUS is the low charge on mercury. Look that up. What is it? It's +1. There's oxide, the element oxygen, always has a charge of -2. Crisscross rule, Hg2O1, which we don't write in. Plumbic oxalate. So plumbum is the Latin name for lead. Ic is the high charge, which is a +4. Oxalate is a polyatomic ion, charge of -2. We're going to do the crisscross rule here, and we are going to reduce those values by a factor of 2. So we should have Pb, and again, the 2 that should be brought down will reduce out. Oxalate is C2O4, and then we bring the 2 down from lead because we've reduced those values down. Here we are going to come up with the name. So again, naming them is always a bit tougher just in case the formula has been reduced, but we reverse the crisscross rule. So if you see AuF3, this is telling me that 3 is the charge on gold, -1 would be the charge on fluoride. Go and check them out. Okay, they have to match, and both of them do. Okay, so gold does have a charge of +3, and fluoride does have a charge of -1. So we know it hasn't been reduced. And so we're going to call it by its classical name. So gold is aurum. That's a high charge. We're going to change it to auric fluoride. Next door, we have SN bracket IO3 bracket 2. So the 2 gets reversed and goes to tin. There's nothing after tin here, so that tells us that iodate has a charge of -1. Go check it out. Tin does have a charge of +2, and iodate does have a charge of -1. So we know that they haven't been reduced. Tin's Latin name is stannum. +2 is the low charge, and so we're going to call it stannous iodate. Down at the bottom, we have CoCl2. So we're going to reverse those crisscross rules. So 2 will come up to cobalt, -1 to chloride. Just go check it out. Cobalt does have a charge of +2, and chloride is always -1. So we know it hasn't been reduced. Cobalt does not have a Latin name. It's not on that previous slide. I did not tell you to memorize it. So you're just going to use it as is, but you're going to apply the appropriate suffix. So for cobalt, they don't chop off any letters, and +2 is the low charge. So we're going to call it cobaltous chloride. And how do you know how many letters to chop off? You don't, okay? Practice will tell you, okay, and repetition. So that is how you'll understand for some of them, what the name is when you apply the suffix. And then lastly, we have FeCO3. Okay, so I don't see any subscripts coming down. That 3 is part of the formula for carbonate. So if you want, bracket that, okay? And then that is indicating that you have 1s on either side, okay? That iron has a charge of 1, and that carbonate has a charge of 1 as well. You go and double check these charges, because again, they could be reduced. Iron does not have a charge of 1, okay? So we know it's been reduced. And the charge on carbonate will help us. Carbonate's charge is also not 1. It is 2, -2. So what we know is that this whole thing has been reduced by a factor of 2 to come up with the formula. So we have to multiply everything by a factor of 2. This gives iron a charge of +2, which is the low charge. So what is the name on this compound? It's going to be ferrous. It's the low charge on iron. And then carbonate is the name of the polyatomic.